Thank you, David. That's a very extensive introduction. It covers a lot of the topics I'm going to quickly touch on today. Being the after-dinner speaker, I'll try to be the transition between the learning and the fun and keep this somewhat entertaining. What I'll try to do is just inundate you with a bunch of images and thoughts and ideas and technologies and hopefully spark some conversations to keep the conference moving forward. So I was thinking about the interface. In this HASTAC so far has been so eclectic and so many interesting different perspectives. Interface can be so many different things, as I've heard in a lot of the talks today. I'm going to focus sort of on simply the role of the human, particularly the human body and our technologies. It's been a driving concern of mine in this, I hate to say, over 30 years of exploring in this area. And I see some interesting changes going on just in the last few years that I'll bring up. And then I will be doing this by showing some of my work that I've done with a variety of colleagues over the years, and end on a different kind of twist with one of the more recent projects I've been working on, which is known as the $100 laptop project. That will tie into a number of different things, including the educational side. So I did start in 1974 first working with a computer, and I think of interfaces. The big thing then was we were able to go from the punch card to a graphic interface, meaning a keyboard with a screen. So that was heaven. It could get much better, though. Surprisingly, the interface hasn't changed very radically from that point, maybe just recently, hopefully. That's going to keep continuing. But this interest I had when I first started working with computers had to do with a sense of trying to inject a human presence into the machine at that time. It was very much a scary, technical, big box, only for technical people, certainly not for artists. So that's what really committed me to start dedicating my time as an artist to try to deeply understand the technology, see if I could infiltrate that world, maybe make some changes, influence, try to bring an artistic perspective. And then jumping to early 1980s, I started working in 3D computer graphics, very early stages of that at a research lab in New York. And one of the projects I did was to create a computer-generated character that represented an actor. This was a collaboration with Twyla Tharp, a piece called The Catherine Wheel, and my character was playing the role of a saint. Now, I still have problems with computer-generated human characters, especially as we try to get them so realistic. I felt, why don't we just make up a real character and put them in? But when thinking about a computer representing a saint, especially at that time, there was this fear that computers were sort of superhuman, better, bigger, smarter than us. That isn't quite true yet. But I thought, well, to have a computer character represent a saint, a computer is kind of a superhuman, a saint is a superhuman. So that seemed appropriate. Even at this early time, another key interest I had was combining a physical live presence with a virtual presence. So in this piece, The Catherine Wheel, I was able to composite my character with the live action character and have them interact together. I'd like to show out of this time, just to give you a sense of the period, Dan Rather was doing a special on CBS called The Computers Are Coming, and how this was he's going to affect our lives. And if we could play the DVD, just a little excerpt of a news special.
The computers are coming, as we've seen this week, to affect most areas of our lives. Behold, the human and the computer. this dance to technology by a living, breathing human, and the electronic dancer drawn with eerie skill by a person using a computer, in perfect step. Rebecca Allen, the artist who animated that dancing figure, thinks computers are too important to be left solely to scientists.
It's still true, and it's still sad. Computers are too darn hard, and the interfaces are really bad. I think there's a lot of work left to be done, and my mission in life is to get people. The rest of the things I was saying on that was to get people from all disciplines to help form the personality of this new machine, and this is certainly an excellent example of that group. I went on exploring. I always can mix my research with art and then slip in pop culture when I can, and so I could justify working with this amazing German music group Craftwork as our research in human motion and human facial movement. So out of that came a video. Some of you may be familiar with it. And another part of that idea that is still so important is how to define a specific aesthetic that really draws from the technology. So rather than make a human that looks as close to a human as you can, I really appreciate the idea of stylizing, extracting some of the artifacts of the technology and coming up with a new style. I think that's what's exciting as an artist working with new technologies. But as time went on, I wanted to get more involved with the virtual reality experience. Machines were getting faster, so you could do that. I even took a very bizarre twist in my career and joined a video game company for a couple of years. I couldn't have been more of a misfit, but it taught me a lot about how games are, how the interfaces work, why the interfaces are so intuitive. And I foolishly thought I might influence that industry to do more artistic work, but not a chance. So I went back to UCLA, started the Department of Design Media Arts, and started on a long-term research project called the Emergence Project. What I did is I took some of the ideas that were coming along, like looking at the area of artificial life, very intriguing for someone involved with human motion and the human body, how to set up with a few simple rules, how to get very complex, organic, natural kind of behaviors out of computer-generated models. So this was one area we wanted to work with. In addition, we built our own special kind of game engine and our own virtual environment with the idea of not winning or losing, but just you as a human would explore this environment and get to know the artificial life that lived in this world. Now, I continue to have a problem with VR. I love the immersiveness of the experience, virtual reality, but I feel with this body issue, it's like, well, I'm out here, some part of me is in there, but I know the physical part of me is here, the virtual part's in there. So the metaphor for this piece, there's a West African belief that we have multiple souls, and we have a soul in our body, we have a soul they call the dream soul, there's another soul they call the bush soul that lives in a wild animal in the bush. And I took this as a nice metaphor where I felt, well, some part of me is still outside of this virtual world, but another part is entering into it. The other part about virtual reality is the lack of physicality, the lack of any kind of tactile sensation. So I address this in this interactive installation by using a force feedback joystick. And these are joysticks you might be familiar with, used in games, usually with like car racing games where you hit the wall and the joystick will respond to something virtual. Well, in this project, I wanted to use this tactile sense to convey a kind of invisible bit of information. The piece was shown in different kind of formats. It was in a very immersive format with large surround screens, so you really felt, at least mentally, in this world. What I'd like to do is play a little bit and just kind of explain what's going on in this world as I show you some examples of it. You enter this world, your avatar is this sparkling piece, throbbing sphere in the center. That's your soul, your bush soul. Now, in this case, as you're touching each of these virtual characters, they come to life and start emitting different sounds. It's a kind of way of roaming through this space and making a nonlinear type of piece of music. I don't know if we could have the lights down a little bit. So you're navigating through this space. Each of these creatures have come to life through another interesting area of this research. We built a behavior scripting language, which is an easy-to-use, simple kind of programming language that artists, designers could use to start defining the qualities and characteristics of all the creatures in the world. For instance, here, as my soul comes up to this creature, it comes out of the ground, it performs a dance for me. Different objects and characters would react based on my virtual presence, or they may like one character in the world or not like another. They can have likes, dislikes, they can be shy. This character here is shy, so when I come up to it, it opens up and moves away from me. But when I talked about this sense of physicality, a metaphor in this world was the notion of energy. And there's a lot of places, a lot of cultures, even Western culture, has a belief that certain places have some kind of special energy. Often it's a sacred ground, or churches are built on them, or there's a mountain that people have this belief that there's something special about these places, and you can just sense it in some way. So in this world, there's these special areas of energy like we're in right now, and as you get to it, the way you know that you're there is the joystick starts moving and vibrating, and in this case in very extreme ways as you get deeper and deeper into this space. So it's a way that I can physically get information about a virtual space through this movement that I can't see or hear necessarily. I'm going to just speed ahead to a couple of places in this world. This is just recorded as somebody is exploring the world. Now, you can also enter into the body. Sometimes these creatures will pull you into their bodies, and then you experience the world through their eyes. The avatar's in the body right now. This creature's sort of throwing it around. And the creature can eject you from its body. You can eject yourself. Actually, that's what's going to go on right here. So comes out of the body. There's sort of a tension. Now, the sense of energy is not just with special places, but there's also a feeling of a kind of psychological energy. Very often we can, walk in a room and just sense like an argument has taken place. It's a kind of ability that we have we don't quite understand. But in addition to energy, there is a kind of psychological energy. This character is now jumping into what we call the crazy pit, where the characters get stressed out when this character comes near it. And in this virtual world, the characters can actually see and hear. And when one starts screaming, the rest hear that and they start screaming and everything goes crazy, and the joystick is just throwing you all over the place. they're playing this and they're laughing because the joystick's actually really moving her around. So, after completing that, I was still just not happy with being only in these immersive virtual worlds. I really thought it was time that I didn't just think about the physical body being represented in the world, but how to bring the virtual world out into the physical world. And since I had worked with performing dancers, performing artists in various projects over the years, I did a new project called, that David mentioned, called the Brain Strip Bear. And in this case, I was trying to break down this barrier of the performer on stage and the audience passively sitting, watching the performance. So what we did, I collaborated with a performance group called Osseous Labyrinth, who are two amazing performers. They perform nude, they even shave all their body hair, very androgynous looking male and female, and take the physical body to its extremes in their performance. They may hang above the audience, they may just do amazing things with their body. So I was intrigued by their extreme physicality, and what I did is, this was a piece presented in Germany and Europe, and I'd have 5 screens surrounding the audience. So the audience would come into this space. It's impossible to document, so I just have a simulation here. And the performance would be projected around them. So the audience could not stay still. The audience had to kind of move around, look at things from different sides. And in addition, while they were looking at these projections, the performers, the physical, real performers, would come into this space and confront the audience, which was a very visceral feeling to have this nude performer, coming right up to you or hanging right above your head. In addition, I worked with some technology. You can see a little character up there above, hidden up above. There would be this device called an audio spotlight. That's just a disc, but it can project a very narrow band of audio so that that I would only hear it, someone could be right next to me and would not hear it, a very personalized feeling, as if somebody's right in your ear. And at one point, the performer would come up to audience members, come very close to them. The person they were looking at would start to hear this voice whispering, saying things like, "I know what you're thinking," and various other things. And it was a metaphor for this idea that we're stripping away our layers of privacy, and just, I always thought, well, at least I've got my thoughts. And then I thought, well, at some point we're going to be able to project our thoughts too, so even our thoughts won't be private. Another piece that came out of this thinking is working again in this mixed reality in a kind of collaborative environment where what you would do is you'd put on something I've always hated, but I did it, a head-mounted display with a camera in front, and you would see the world in front of you, and then also combine with a computer-generated image that would appear to be in the same space. Let me show you this in action. So here again, there was the use of our physical senses. The interface here is you actually blow into a microphone that's manipulated. Here's the setup with a head-mounted display. You're holding again a force feedback gamepad, and what you're both doing, you're sitting across from each other. At first, you were blowing away this barrier between you. I could tell what the other person is doing across from me because when they would blow, I would feel a sensation, a tactile sensation. So in this case, I was trying to use breath as an interface and also our physicality. So again, really trying to exploit the body rather than just using our fingers. This led me to work that I did at the MIT Media Lab Europe. I had a research group called Liminal Devices. Liminal is one of my favorite words. It is often used in anthropology and in theater. It refers to that which occupies both sides of a boundary or threshold. And it may refer to like a ritual like puberty or marriage where you're leaving one state and moving into another state, but you're in that in-between state where you're kind of neither here nor there or both here and there. And this, I think, relates so much to the world we're quickly moving into, where we not only are in mixed realities, where we're plugged into our virtual technologies. Cell phones are the usual example. We can barely spend 5 minutes without also being on a cell phone while being in our physical space. But it brings up the issue of life in simultaneous realities, that what we're doing with these devices is we're in a sense wanting to be in more than one place at once, whether one is virtual and one is physical. And then I had this particular interest. Now, instead of the body being this virtual thing inside the computer, I could start working with the physical body and attaching physical sensors, physiological sensors to the body that would become more and more the interface. So this is something, an area we call intimate interfaces. It's actually been accepted as, in the human-computer interface community, as a legitimate area of research. And it has to do with using the body as the interface. We worked with breath, muscle movement through EMG sensors, finger movement. I also worked with brain signals through EEG, bone conductance. In the end, it's thinking, how can we deal with this? How do we focus our attention, or how can we split our attention? How can we coexist in these simultaneous realities in a way that is not overwhelming, maybe enhancing our experience? One thing I worked with are glasses that actually have displays embedded in the glasses, so I could get rid of that astronaut-like head-mounted display. Here you can see, might see a little bit better, kind of like a bifocal. You've got your display in your regular glasses. These are coming very quickly to the market. They're available now, but expensive. And what happens is you can see an image, you can set the focal length, but it can be an image hanging out in space. Now, we use this for this notion of intimate interfaces in one project we called Myophone, taking the reality of mixed reality, and simultaneous realities. What happens, take the cell phone, we're in a physical space, and what happens, the phone goes off. There's no reason it has to ring. It's disrupting everybody around us. It's disrupting the environment. So we were looking at a more subtle interface just for the cell phone. We embedded LED sensors in the frames of the glasses. So here would be the situation. You'd wear, like a patch, you'd wear a wireless EMG sensor that could sense subtle muscle movements, and you'd have your glasses on. You would get a call. With my glasses, I could tell in my peripheral vision that I'm getting a call. I just slightly tighten my bicep. I get on my display who's calling me. I tighten again. I send a message back saying I'll call you later, whatever I want to say. And all of this has happened. I could even be having a conversation. I could be doing it right now. And the environment wouldn't be disrupted. It's maybe a kind of crazy idea, but not so crazy when you think of where we're going and that we're becoming so attached like cyborgs to our various technologies. My students couldn't live without their cell phones, and more and more all of us are getting very attached to being in these virtual worlds while we're in the physical world. So this is some of the setup there. I even looked into EEG. I was interested about brain signals. I won't go into that because it's a little more complicated to talk about, but yes, we will be able to more and more decipher our interface through our thoughts. Just already now we can move cursors around and do various things just by thinking about it. It's going to be an interesting area of research. Brain-computer interfaces has really exploded. Another area of mixed reality is working with, some of you may be familiar, you can use these kind of graphic markers, these codes. They're actually, like in Japan, using them, you may see a poster and there's a kind of barcode type thing. You can take your cell phone with your camera, put it up there. That code is a code for some kind of information. You put the camera up and you get a website link, for instance. So this is an interesting area we played with. One thing we wanted to do is just not make these barcode graphic type things, but we've gotten it to the point where you can start to use visuals, design your own graphics. Something like this, Media Lab Europe, could also be a code that would bring up various kinds of visuals. And I think there's some really interesting applications with this. One thing we did is looking at a kind of physical game where you walk through a space and you would have these embedded displays with cameras, and you'd be wearing these hygienic gloves with these codes on them, and as you come up to these various places, you would get different kinds of images. Here's something we did with people. You'd come together and they'd start communicating with each other. Let me show you a couple other examples. So what you could see might be clues to a game. So as you open and the computer sees this code, it can bring up whatever kind of imagery. We looked at collaborative applications. So if I had one image and you had a different code with another image, but we came together, we might be able to discover in this game a third image, or we may be able to pass one bit of information over to another player. And then we took it to a point, sort of a playful point of a sense of a magic mirror, where you buy a shirt and you've got your logo, and as you look, you're looking at yourself, there's this additional image that you're carrying around with you, and that could change. You could look at different mirrors and get different kinds of images. And in a learning context, you could, we're going to be doing some experiments where you can place these abstract graphics, graffiti-like, throughout physical places or even natural places. And as you go up, you can learn information about that physical place. So I think this has some interesting potential as an interface. Then another thing I did while I was directing this group is an art piece called Liminal Identities. And this, again, was trying to be thoughtful about what's happening as we're living in these liminal worlds, and that our identities are also in this liminal state. It was, the way the installation was is there was a physical box, like a packing crate, that had 2 holes on each side of it. And so people would come up, how I feel in virtual worlds. It's like my head's in one place, but my body's in another. And inside of this, we had this contraption of mirrors and projected images, and you'd see your face mixed with the person across from you, mixed with graphics. And you're in there playing around, but unbeknownst to you, there's a camera that is taking your face, taking pictures of your face as well. And then you would go over to another part of the installation, which was a projected 3D world. This is something we used the Unreal game engine to create our own virtual world, kind of very Irish landscape-like. And you would be interacting with that separately, but you might find your face coming out of this virtual box and into this virtual world. There's this idea that, you know, we think we've got this great interactive control of everything on the computer, but we know everything that we're doing and we're controlling. Every keyboard stroke can be recorded. Our passwords are there. You know, we're actually giving a lot of our identity into these systems in order to have this kind of interaction. So this notion of control is interesting, that, you know, while I'm controlling what I'm doing in this space, a part of me is being taken and being put over into another place. The interface in this part of the installation was again using breath, so by breathing you would move yourself through this virtual landscape, and there was a story behind it which I won't go into now. I'll bring up one other project that came out of the Media Lab Europe and ties into interfaces, again using the body, project called Body Mnemonics. So it turns as much of the human body into an interface, capturing gestures and motions to access applications. So you'd have a special device with accelerometers and different senses. So instead of just sitting on your PDA, typing up something, bringing up information, you might say, okay, I want my financial data. So symbolically, I've, let's say, stored it in my pocket where my wallet is. So I take this device, I move it here, it recognizes that gesture, brings up my financial information. I might have my close friends or something personal on my heart. I make that gesture, it brings up that information. It's a way to think about using your body again in a more clever way to help assist as an interface. Because I think interfaces just have to become more and more natural, more connected to our body, utilizing more of the complexity of our body. The Wii that Nintendo's come out with, I think, is really going to point to some interesting new directions in interface where your gestures and movements really have a lot to do with how you interact with your technologies. Now, to jump onto a topic that's a little bit different. After leaving Media Lab Europe, Nicholas Negroponte, who also founded that lab, started this new project, probably a lot of you have heard about, called One Laptop Per Child. And very simply, the idea, it was inspired with his sense that children are our most precious natural resources. A solution, he thinks a solution possibly to poverty, peace, environment is education, not necessarily technology. This is an education project first. And that teaching is one but not the only way to achieve learning. You might know Seymour Papert's work in constructivist learning, and certainly something artists have always understood, that you learn by making things, by doing things, by physically putting things together, by doing stuff, not just doing what you're doing, having to sit there listening to a lecture up here or reading your textbooks, taking tests. But a lot of the real learning takes place by doing things and by learning from your peers, and now, of course, with the internet. So, One Laptop Per Child, it's a nonprofit. It's very important that it's global. It is going to launch these laptops that we've been designing. These special laptops will be 3 to 5 million in September of this year across at least 5 diverse countries. The first focus is in developing countries. This laptop is very much made for kids, for education, in very extreme environments that a lot of these kids live in. And it's important to Nicholas that it's not a computer lab or one laptop for every 3 kids. It's that the child owns their laptop, they take it home, they do what they want with it. They can use it in school, of course, but they can use it everywhere. Areas of interest for me, besides just I love that this is a big, risky project. There just aren't that many examples out in the world today. And yes, there's the downside, and I know all the problems that can evolve, but why not? So it's an opportunity to rethink the PC, a lot of things about the physical laptop that we've had to endure. We did take away the caps lock on the keyboard. No one could figure out why that has such a prominent place, and all it does is turn itself on and make trouble. It's dedicated to Linux to keep costs down. Linux is a free operating system. 25% of your laptop costs is the operating system and associated software. Also dedicated to the open source software movement, free software. This is really going on all over the world. There's a huge collection of people in these developing countries and elsewhere trying to make specific software for this project. Being very power conscious, which suddenly has come to the forefront of our world with people finally recognizing issues like global warming. Our laptop is about, on average, 2 watts of power, where a typical laptop's 35 to 40 watts of power. Because of this low power usage, we can utilize human power to power the laptop. Not exclusively. You could if you get a lot of your friends and sort of do it all day. But the goal is to have we're developing 2 human power devices. They've got to be under $10 cost, and they have to, for 1 minute of use, generate 10 minutes of lap time use. And we're well on our way to doing that. Again, I was really pushing for the human power because to me it brings in the human body again. It's like instead of all the kids, getting fatter and fatter sitting in front of their computer, we should all be using our bodies to generate power, not only for laptops but a lot of our devices. Hopefully that idea might rise to the occasion. It's shocking how little work is being done right now with things like human power. There's only really 2 companies in the world that have tried to do anything with it. It's pretty surprising. That hopefully will change. No bloated software. It's intentionally a low-powered machine, but keeping everything stripped down. Nicholas believes featureitis is killing us all. We have to buy faster and faster computers just to run the same software because it gets fatter and fatter. It uses a mesh network, which is a way to communicate whether you have internet or not. You can communicate locally with a mesh, so you can communicate to your community and then even beyond your community through a mesh. And then, of course, you can use the mesh to connect to the internet. Lots of work going on in getting internet, cheap internet access into these countries we're looking at. And then, of course, peer-to-peer, everything, learning, playing. Partners, I'm not going to go too much. These are people who help in some way or another in addition to providing some money. United Nations is helping a lot with distribution. We're getting help with we're going through ministries of culture and how to finance this. That's a whole tricky thing, but lots of people involved in that. The largest laptop producer in the world, Quanta, is manufacturing the laptop. Launch countries, these are the countries. Very soon we'll know the final list of initial countries. These are all the most likely ones. And then I was the design manager for the industrial design for the laptop itself, which was just a real exciting thing. Getting physical for me, thinking about the physical object. You might have run into this picture. This was the first prototype with the idea that there's a crank on the side. The crank was not feasible to put in the machine. It was too much stress on the machine, so we had to take the human power out of the machine but keep the notion of the human power. Early on, the idea was that you could use it in laptop mode. You could also flip it around and use it like an electronic book or horizontally, kind of like a game machine format. And this has stayed in the design. Some of the design iterations we went through, thought you might see, here's where the crank, we are still dealing with a crank. It's sort of integrated nicely there. You can open it up and use it as a crank. Another idea, each time we do a prototype. We try different colors. We have all sorts of colors. I think green and white is the final color. We have this logo, which went through some changes. The machine itself is called the XO machine, and based on this simple logo that was initially designed just as an idea, and we adapted it, thought about adding a handle. There, the crank is on the top. We tried that as a possibility, then finally took it off. We need to cover all the openings. The worst enemy of this is dust and dirt, so any of the input connectors can be sealed in this design. This is almost getting to the final machine, and this is the final machine. As I mentioned, what we did is we have a transformer hinge, so you can rotate it, flip it over, use it in this either vertical or horizontal with these control buttons here. I pushed really hard to have a camera in it, and it did get in at the 11th hour. So we've got a camera. I think that's crucial. A microphone, make it a media platform. These little funny rabbit ears are actually the antenna because we really want to optimize this connection with the mesh. Just by putting, like the old-fashioned rabbit ears, putting the antenna up gives you an increased signal. They also play a role, I mentioned, when they're down, they cover all the openings. The only visible opening is for power, and that's a sealed off connection. You can see here the other connectors, 3 USB ports, rubber membrane keyboard, a kind of touch-sensitive tablet. There's a prototype of one power device. It's a string device. You pull like this, so you can hook it onto a tree or put it wherever you want. The other is a small crank. The mesh I mentioned. User interface, which I haven't been much involved in, is a whole new metaphor for interfaces. This is very radical. Hope it all works, but you have your home view. It's very connected to social computing. Here's a local view, and then here's a larger mesh view with the activities or the applications and it's the software setting up so multiple people can work on applications together for collaborative kinds of learning. So, whipped through a whole lot of ideas, but hopefully just something to spark your interest and further development and new ways to include the body, keep the body there, move us out more into the physical world. And I guess that's it. Thank you. Yeah. I think we've got a few minutes for questions. About 10 minutes for questions. If people, there's some microphones up here if people would like to come up.
Okay, is this, okay.
Yeah.
Allison Clark, Seedbed Initiative for Trans-Domain Creativity at the University of Illinois, Champaign-Urbana. There seems to have been a theme through the keynote speakers of all this wonderful work that's being done globally. I think the $100 laptop is phenomenal, yet we here in America are faced with globalization, the world is flat, the gathering storm. What about our kids in our country and a $100 laptop for them?
I'm always asking this too, and there will be, it's interesting, you take a country, I think Brazil, spends maybe $50 per student for education. In the US, we spend more like $4,000 to $6,000 per student for education. Now, you might say, we do? You know, what are we getting from that? But there's such an extreme difference in that. I know it will probably very quickly come to the US. I believe Nicholas has this vision where he wants it to really start at the most extreme environments and extreme situations, We're talking about kids, if they have a school, if it's often under a tree. I should mention the display is unique because it can be in black and white mode, high resolution, sunlight readable. The only way you could have a computer in a lot of these kind of school setups. And often kids, the teachers very often don't have beyond a 6th grade education. Often they don't even show up because of lack of pay and other issues. So there's really extreme situations that you're talking about in the environments, and we're particularly trying to go to those environments first. But I understand your question too. I mean, it will happen, and the state of Maine is providing laptops to its middle school kids throughout the state. Other states are doing some kinds of variations on that, but we want, you know, with this much lower cost laptop, it will get to the US for sure.
Thank you.
Hi, thanks for the talk. Ian Bogus from Georgia Tech. I'm going to ask you a question about the EXO that's not really fair to ask you, but I'm going to ask you to give your opinion maybe on this issue.
Okay.
So I've been working along with many others, and I've been working much less than many others in the group, trying to figure out how to make games run on this machine. And there's a kind of dirty secret about this machine, which is that it's actually quite difficult to get software to run on it. And the question I want to ask is about open source, right? Because we've heard a lot of discussion about openness and open access. And one of the reasons I think that it's been harder to get things running on a machine like this is because open source has become kind of an ideology rather than a philosophy. So in what ways does open source actually kind of prohibit or kind of constrain success in a machine like this, where we actually have things that work, that run, right? Even on open platforms like Linux that aren't being used, right? So this is kind of not your fault, but I'd love to hear your opinion on this issue.
Believe me, I am the thorn in everyone's side on this because this has been my mission in life. I've spent many years with software developers and always saying it's not easy enough. And you know that's true whether it's Macs or Windows or Linux or open source. Because it's open doesn't mean it's any easier to work with. If you're working on it, you're probably seeing there's a new build, like a whole new version of the operating system quite frequently with all the improvements. So there's a lot of scrambling to get all of these pieces into place. And if you're working on it, you're in that tumultuous time of having to work with partly working, now this is broken, now this got fixed, now that, bring it in. And so there's that issue too. But I believe what's going to happen, you know, that I'm working with a lot of MIT and computer scientist types, and they're sure that everyone's going to be in there being a programmer, and I'm going, no. But fine, it'll be easy to open up and figure out how to be a programmer. But there's also another part of this, which is working with lots and lots of textbook providers from all different countries to get their material easily into an electronic book mode. Just certain things, working with multimedia, which has been slowly moving further ahead. Games, I mean, this is not going to be a 3D game machine.
Yeah, I mean,
because of the
I just want to,
processor,
right, and this isn't really fair to bring up here, but I kind of feel obligated to, because this is such an exciting and it's really persuasive story, but people think that their Flash applications can run, they think their Python applications can run, they think their Linux applications can run, and they really can't yet, right? So I guess I just wonder in what ways are we almost kind of the shortest path to getting this stuff out is not actually the open source path, right? So what do you think about that, right? Is that really a problem for this platform?
Well, I was hesitant about open source from the beginning because I'm not an evangelist in it, but I've learned that what open source, a really big thing in this project, what open source can allow is to get locally generated material. And a lot of the non-open stuff that's out there is culturally and for various reasons, it's not appropriate for the kids that would be getting these
Right.
machines. So
Yeah.
the open source has opened up in all of these countries. There's actually some really hot open source development going on, and it's given them a real push to create stuff or to move their stuff along that's very specific to their country or their region. So I've come to appreciate the open source for different ways. I don't think there's anything about open source that makes the user interface or working the
Right.
programs any better. I think people just have to keep banging on them. Now, what's happened only recently are these machines are now going out, the working prototypes, being used by regular old people, not just, or regular young people, not just programmers. And, the kids, the teachers are like, what, huh, what? So, like
Yeah.
any software development, they're always so afraid to get those
Yeah.
regular users on, but we're in that stage now. So some of these
Yeah.
questions are being
Right.
pushed along.
Thanks for the comments. I guess I just want to also say for everyone listening, the groups working on this are completely open to anyone, almost anyone participating, right? So
Yeah.
if there's anyone in the room who's interested
Sure.
in this project,
Yeah.
it's worth noting that they can get involved.
Yeah, and that's kind of a nice thing about it too. It's such a goodwill project. I mean, there are a few thousand programmers around the world working on this. Now, whether everything they're doing will be useful or integrated, maybe not. But it's there's no problem in getting people that want to in some way contribute. So that's where the open source movement, I think, has come about too. And what we've done, well, to me, the most important thing, it's almost as if this laptop doesn't even come out. There's been some huge things happening in the computer industry, which you might have noticed. Intel, who were the first ones we approached, and they said, stupid idea. We went to AMD, their competitor, that's the hardware in it. Intel went into a panic. Intel is completely mimicking, there may be someone from Intel here, but it's true, mimicking this project, and they have suddenly come up with the $400 Classmate PC, a laptop dedicated to developing countries specifically for education. And they would never have done this. They are moving so hard, and they're trying to get their price down further. We're open even about our industrial design. Their laptop looks suspiciously like some of our earlier industrial design models. But we keep saying, do it. If we're nonprofit, you aren't our competitors. We need more than we can produce. We're going to produce minimum of 5 million coming out. But Bill Gates has also panicked because, of course, with Linux and open source, it's a very interesting idea to use Linux and open source. They've been a bit on the sideline. If the numbers add up the way, you're talking millions, that's going to make Linux and open source a very big contender. And to have millions of kids being familiar with this, of course, makes other companies very nervous. We know the open source and closed source have been struggling, but this is phenomenally driving that discussion far ahead. Now, all we have to do is not have Intel try to destroy us, or Microsoft, which sadly there's a little bit of that going on too. It doesn't make sense, but they're competitive, and I guess that's how they naturally go. So that interested me too, is that this is shaking up. It's like I get so mad when these programs take up so much space and have so many features, and it's like, will anyone listen to us? There are too many features, it's too big. And we're saying, well, at least somebody else is trying to do it a different way, and that's it's really forcing a lot of industries to do things differently. We've got companies designing the $10 DVD player, the $100 projector, we're developing a $100 server. It's incredible what this has done to the technology community, even with the machine not out yet. It's really driving a lot of innovation in a good direction, I think. Okay. Sure. I don't know. Stop me if. Okay.
So quick comment about open source. If freedom is an ideology, let's use free software instead of open software. And if freedom is an ideology, then you can count me in. I'm sorry. And I think but my question is not, can the software support the playing of video games or Python programs, but can it support things like the editing of Wikipedia and other applications like that? Yes,
Yeah.
I mean, what's the basic web support that this $100 laptop would provide? And second, how you can make 1 million of these things, as Alan Kay said, but how are the user studies going? I mean, do we need to produce thousands of teachers for these laptops, or are they so intuitive, is the interface so remarkable that you can actually literally give it to people and they know how to use it? And I guess, and my last question is, how do you see, you can clearly see that if these $100 laptops were available, they would produce, you know, massive more access to information in developing countries and in very poor regions. And do you think that access to information alone, say through Wikipedia and through the web, is that enough to help in a realistic way solve the political, economic, and social inequalities that are perhaps keeping a lot of these countries in the quote-unquote developing world? Because I think there's a whole critique of development which is, would complicate that question immensely, to say the least.
Phew. Well, Alan Kay his project Squeak is on the laptop, as you probably know. So he's actually certainly been behind this all along and is pushing it along as hard as he can in certain directions. There was a middle question in there. The web. So there's, you mean, is there a special browser? There's actually work, and Alan has one foot in that too, in working with Wikipedia. There's, I don't even keep track of it because there's so much going on, but there's a whole area of interest in how you get what information off the web and how you can cater that to certain communities and how you can do that in an easier way and get to Wikipedia in easier ways. And then your other question was about, tell me again.
What problems does the laptop solve?
Education. So what OLPC isn't doing is saying, okay, here's these 25 applications we have developed to help you learn so that you will solve all of your problems. We're presenting a tool, trying to make it as usable as possible, but relying a lot on local groups, which are happening right now, to develop things that they think are particularly important to them. And what Nicholas says, if people say, well, do these countries need a laptop? Don't they need water and food and medicine? And he says, if you substitute the word laptop for education, people don't ask the question. Now, education, who's to say? I mean, if I'm a 6-year-old kid and I find out through the web about a certain disease or, malaria, that it can actually, I can do this, this, and this, and I can figure out a way. I think there's a lot of information, not just on the web if you don't have a lot of access to it. There's books, encyclopedias, that are downloadable. We're putting a lot of stuff on these school servers, so you have a library on your server, something none of these schools ever had. So what it's doing is just increasing your opportunity for education. Now, what kids and teachers do with that, I believe that there's a lot of innovation out there, and people will figure out ways to make it applicable to their problems and to help them solve some of their intractable problems. Okay, I think that's it. Thank you.
Join me